Okay, so problem number 3 states that the particle of mass m starts at rest and moves a vertical distance in the presence of gravitational field. We have to find the work done by the force going to G1 10 meters, so the initial position is 10 meters, and it stops at 6 meters. So we have an object at 10 meters initially, and it starts falling until it reached the 6 meters. So the equation to find the work done by the force, it's equals to the following. Displacement, they're not giving us a specific mass, so we could assume that the mass of the object is going to be, let's say, 10 kilograms. And since we know the object is falling, the force goes in the same direction as the distance traveling. So therefore, we could assume that they're both positive, right? So let's just assume that the force, distance travel are going to be positive. So it's easier for us to work with. So the force can be found multiplying the mass of the object times the gravity. And the delta S is going to be E2 minus E1. Okay, now let's plug in our numbers into the equation and find the work done by the force. Mass of the object, 10 kilograms times 10, which is the gravity, times 6, which is going to be the final position minus the initial position. And this has to be positive. So work is going to be equals to 400 joules. Okay, for the second part of this problem, we have to find the velocity when the object is at 6 meters. From the first part, we know that the initial position of the object is going to be 0, and we need the velocity at 6 meters. The equation that we're going to use to solve this problem is work is equal to the variation in kinetic energy, which is half times mass, final velocity to the second, minus 1.5 times the mass of the object times initial velocity. And we know, or we said that the mass of the object was going to be 10 kilograms. So all we need to do is plug in their values into the equation. This side of the equation is going to cancel out because the initial velocity is 0. So it would be 1/2 times the mass times the final velocity to the second. So the final velocity which is B final. To the second, it's gonna be equals to the work over the half of the minutes. So now let's just plug in the values to find the final velocity. We know that the work, it's 400 joules. And then the mass is 10 kilograms. Simplify this is 5. So now it's 400 joules over 5. Which is going to be equals to 80. Which is going to be the final velocity to the square. To the second. So now all we need to do is find the square root of 80. This is going to give us the final velocity. Final velocity will be equals to 8.9. We have found the final velocity and the work done by the force.